All right. Hello, everyone. I am Bill Dorfeld, Editor-in-Chief of Nordic APIs, welcoming you to another Nordic APIs livecast. In this event, we'll be exploring the AsyncAPI specification and learning from the experts about how to best leverage it to guide asynchronous development. Asynchronous and event-driven architecture has really been on the rise lately, so I think this is a great time to meet with some of the key figures propelling this field forward. We also ran a poll recently, and by a landslide, this topic was our most voted one by our followers. So I think that just demonstrates the interest in async styles right now. So for those of you who are maybe a bit unfamiliar, AsyncAPI is a newish standard specification for describing asynchronous APIs. The open source API definition is backed by the AsyncAPI Initiative. And by using AsyncAPI, you can define your async APIs in JSON and YAML to create a machine-readable format. Now hosted by the Linux Foundation as of early 2021, AsyncAPI is billed as kind of an alternative to OpenAPI specification, as it caters to different protocols like AMQP, MQTT, WebSocket, Kafka, and others. So using AsyncAPI, you could help with interoperability and make it easy to represent APIs with great documentation. On that note, one benefit of working with any open standard definition is that you can utilize all the compatible tools in the ecosystem. So if you have an async API definition, for example, you could easily generate human readable documentation for the service, or you could incorporate your definition into trigger-based development with GitHub Actions, or AsyncAPI could even help a specification and design-first development strategy. So that's kind of a very high-level overview of what AsyncAPI is. And to dive deeper into this subject, we are honored to welcome two expert speakers today. First up is none other than founder of AsyncAPI Initiative and someone we've featured through Nordic APIs quite a bit, Director of Engineering at Postman, Fran Méndez. Fran will be giving us an introduction to AsyncAPI and the surrounding community initiative, and exploring the future of API specifications. Also in this event, we're welcoming a new face for Nordic APIs, Ben Gamble. Ben is head of DevRel at Ably Realtime. He'll be exploring why async communication is on the rise and how to manage it in this new paradigm. I just want to remind our real-time listeners that if you're watching live, you can submit your questions and we'll try to answer them all in the Q&A session right after these two sessions. So with all that said, take it away when you are ready, Fran. Very glad to have you on the call with us.
Well, thanks, Bill, for the great introduction. I'm honored myself to be here, so
Awesome.
Yeah, thank you. Let me share my screen and configure everything so we can get started. Cool. So that should be working, right?
Looks good on my end.
Okay. So yes. Okay. Cool, folks. So, well, thanks everybody for joining the livecast today, the Nordic API livecast today. And my name is Fran Méndez. I work as a director of engineering at Postman, and I'm also known for being the creator of the AsyncAPI Initiative and the AsyncAPI specification. So yeah. Today, I would love to explore a kind of different topic, related topic. So usually I tend to talk about AsyncAPI exclusively, and that was creating a little bit of let's say it was worrying me a little bit because I was like only focusing in one single thing, AsyncAPI all the time, right? And nobody is using AsyncAPI alone. Nobody's doing event-driven architectures alone. Nobody's doing REST APIs alone. Nobody's doing GraphQL APIs alone. So we all work with different styles of APIs, and I would love to explore what the future of API specifications could look like if we make it happen. So it all depends on us, you included, not just the ones that are working currently on the specs, right? So let me tell you this. Let me explain what I'm thinking. What I think it's the future of API specifications as a story, right? So this is a beautiful Stockholm. So I think Bill is familiar with this picture, maybe. And and yeah, so I was invited at Nordic API Stockholm in 2018, and I was like I said, I was honored to be there. Actually, I think it was a keynote, so I was even like I was, you know, super freaking out and nervous, right? Because I came there to announce that I was dedicating full time to AsyncAPI, and that it was for the first time in history for AsyncAPI, it was backed by companies, right? By other companies, so it was sustainable. And at the end of the talk, uh, in the usual questions and answer section, a guy raised his hand and asked about, is it like Avro schema, or is it a replacement for Avro schema? And I was like, well, no, it's a, you know, Avro schema is to define the data and of the message, and this is more for the API itself, right? Like how you send and receive message, where to connect to receive message, and all in all, right? And and like after the question and answer section, out of the talk already, offline, two guys came to me to talk, and it was funny to see to me. It was funny to me that what happened at that time was right one right after the other, they both asked the same question, which is very unlikely, and they were both asking, have you thought of merging with OpenAPI? So AsyncAPI and OpenAPI can be a single spec. And I said, like, well, yeah, we thought about it, we discussed about it, and we decided not to do it for reasons being the majority of the reasons were not to put too much pressure on the tooling vendors, right? Because it's already complicated to provide full support for OpenAPI or full support for AsyncAPI. So if we have to provide, if someone has to provide full support for OpenAPI plus AsyncAPI, then it's like, this is a mess. It's too much, right? So we decided not to go this way. But we kept collaborating, OpenAPI and AsyncAPI, we still keep collaborating. It's not that we don't want to merge the specs, but we want to stay closer to each other. Then I was invited to go to API Days Paris same year, and this was my first API Days in Paris, and luckily, I mean, I was lost there, like I almost knew no one, but luckily King Lane was there to lend me a hand, and I'm always super happy to you know that I met him at least, so I could get introduced to somewhere, right? Also, my friend, who's now my friend, NJ Jersina, was there, and he introduced me to Samir and Sunny from Adidas, and we had like a super great chat about API management tools, how they were imagining this at Adidas. The cool thing about it is that the cool thing about this discussion is I was like explained again that uh, they wanted to have everything in a single place. So they wanted to have the REST APIs developer portal and the Async API developer portal and the GraphQL developer portal and everything in a single place. And that was impossible. And so they were even telling me like, hey, if you develop this and sell it as a product, we buy it. You know, it's like we want it, we need it. We're maintaining something in-house, and we shouldn't be doing that because it's a lot of work and it's providing as little, very little value that should be externalized. So yeah, right after that, next year on 2019, I was helping organize and also speaking at API Days Barcelona, and we were in the speakers dinner the day before, and we were at the bar in the in the historic neighborhood of Elborn, and we were at the bar with a beer in my hand, and I was there like hanging out with colleagues, and again, the same question repeated, like I think it was like 2 or 3 times during the whole night. Like, have you thought of merging with OpenAPI? And and I was like saying the same response, like, no, it's too much pressure for the vendors. And of course, people reaction was like, okay, but okay, but not okay, right? Is this was like uh, not my problem, right? It's not their problem, and you still don't solve my problem, and nobody's solving their problem. So yeah, they were like, okay, I kind of understand you, but not my problem again, right? So why am I telling you these stories, right? I want you to think about it for a moment, like I did at the time. Like, so this question has been bugging me for years, for a lot of years now. Like, why people want us to merge with OpenAPI? Like, is it? I don't know. It's not. It can be interest. It can be any other um, other obscure, let's say, or dark um, thoughts or anything, because some people are just like users and they don't care about OpenAPI, AsyncAPI, or any spec. They just want to use them. So it was like, why is it like, why are them interested in S journey, right? I'm not gonna answer this question now. I just want to look you. I just want you to look at this. So this is the current, let's say, the current ecosystem of specs and API styles. So you have REST, GraphQL, gRPC, or RPC, messaging, and SOAP, right? And then you have a bunch of API specifications. These are not all the specifications that exist, but these are, let's say, the primary ones for each of the API styles. So what happens is that if you're gonna do REST, you probably have to use OpenAPI RAML, and if you're using OpenAPI, you have to use JSON schema. If you're gonna do GraphQL, you probably know, you for sure have to use GraphQL schema because it's mandatory. If you're doing gRPC, then you probably have to get familiar with gRPC format and protobuf format. If you're doing messaging, then you have to use AsyncAPI because that's the only option right now. And inside AsyncAPI, even if you don't know, you're using JSON schema. By the way, same as with OpenAPI. If you're using OpenAPI, you're using JSON schema even if you don't know. And optionally, we also give you the opportunity to use Avro and RAML data types with AsyncAPI, right? RAML is in yellow there because you cannot use the full RAML object, just data types for RAML. And SOAP, well, some people think it doesn't exist anymore, but it's still there. So still there for a long time, I guess. So then you have to use either, I don't even know how to pronounce this correctly. I always call this Whistle because I think it sounds cool. Or you have to use XSD, right? Not or, and you have to use XSD, right? To define the data model. So again, if this is the ecosystem of API styles and API specifications, why people want us to merge with OpenAPI? Because it's like, if we merge with OpenAPI, the problem is still unsolved. You have GraphQL, you have SOAP, right, with Whistle, and with gRPC, you have many other specs. So then probably people want us to merge with OpenAPI, and then what? And then we'll have to merge with gRPC and with GraphQL, or how is it going to happen, right? More than how it is going to happen, I'm more interested in the why, right? So why people are again asking us this. So let me just get back to this. So do you really think that people want a single spec with all this ecosystem? I don't think so. I don't think that the interest is a single spec. maybe, I don't know, people want to define any kind of API with a single file. I mean, could be, but API specifications are often composed by multiple files. You divide the spec in multiple files, so I don't think it's having a single file. And so the conclusion that I came with is, in my humble opinion, I think people are just looking for the one tool, the one process, the one workflow, if you want. So you just do one thing, and it's the same for any kind of API, right? Any kind of, if it's REST, GraphQL, gRPC, and they don't care if it's OpenAPI, AsyncAPI, GraphQL, gRPC. It's like, I want to do this style of API, and I want to provide this value to my customers. What's the language that is going to provide the best support for that? I don't care. This is something that only spec authors are working with, but the users are like, don't tell me don't tell me your problems, and it's just give me a solution, right? Like I was saying before, they were like, okay, I understand, but I don't care, right? So I think it's just like one single process, one workflow, and then just do something for REST, and then you do the same for GraphQL and gRPC and messaging and SOAP, and it works. And you don't have to be installing different tools and that are in this tool you do this like this, and this other tool you do these things differently, and then nothing is compatible with each other. So I think that's the key thing, and also because we like API practitioners, I would call myself or ourselves API experts. Maybe someone is, but API practitioners, those who are a little bit more than the average interested in APIs, um, they're cool with this because it's like, oh, this is like a game, right? I need to learn this new language, these new tools. This is cool. But for developers in general, they don't care. It's like, this is just a piece of the puzzle, right? This is just, I just want to get security sorted out, deployment sorted out, storage sorted out, and now I want to have API piece sorted out. For storage, you have SQL or ORMs, right? So you have SQL and no SQL and NoSQL. Um, but you have all ORMs that can handle this for you, so you don't have to rewrite your queries. It will do it for you depending on the backend that you have, right? For deployment, there are many systems that now with Kubernetes and many other systems, this is becoming even more famous, let's say, right? And mainstream, and security, same way. So for APIs, we're still asking developers with non-specific interest in APIs to learn all these things just to be able to provide a good API experience, good API development experience. And I think the experience there needs to be seamless, right? Not as it is right now. So how do we solve this problem without merging into a single spec? Because we cannot merge all the specs into a single one, because that's unlikely to happen, to be honest. So, and not because it's not technically possible, but there are business interests, there are, it's all people in the end. So like getting people aligned into a single, into a common, into a common thing, right? Into going in a common direction, it is simply, I will say, impossible. So what will we have to do without to provide this experience without merging into a single spec? So I think I took the time to evaluate how it is the state of the API scene right now, and evaluating as in um, realizing which ones are in the good direction, in my opinion, in a good direction, which ones are not in a good direction or non-existent, or and also which ones are like kind of there but still needs more. So as you can imagine, green is for those who are are, I will say, doing well. These parts of the spec, the space, the API space that are doing well. Red is none, and yellow is kind of, right? So, so I divided this by specs and tools, right? So we have different specs, but then we have tools to work with the specs. And and I would say that specs, you have everything listed there, like uh, I think multiple schema definition languages, paradigms, and protocols. This is really possible, at least with AsyncAPI, it is possible. So you can have different um, like client server and broker based architectures defined with AsyncAPI, and you can have multiple protocols, and you can have multiple schema definition languages like Avro, like JSON schema, right? So it is like RAML data types. So it is already possible. So that's cool. Then on spec side as well, most of them are extensible. So I will say that I think GraphQL and gRPC are the only ones who are not providing an extension mechanism. I'm not sure though, but um, this is kind of there, right? And then I think specs need to become composable. What do I mean by composable? So if you have if you have a spec, like for instance we do in async API, we have the possibility to use the HTTP protocol. And if you're going to use the HTTP protocol and you're going to interact with an HTTP endpoint, then why should we be defining this on Async API? Why can't we leverage OpenAPI to do that? Like OpenAPI is already defining and giving you the opportunity to define how to interact with an HTTP endpoint, right? So let's leverage that. So let's embed OpenAPI or a part of OpenAPI inside Async API. That wouldn't be new because remember, like I said before, JSON schema is already embedded inside OpenAPI and Async API. So it's not something new. And we're also using URLs, which are URL is another spec, is another RFC, right? So we should be composing more between the API specs themselves. Then tooling need to catch up here. So problem with tooling is that, uh, for instance, in our case, we build our own parsers and validators, but OpenAPI doesn't maintain any tooling. GraphQL maintains their own parsers and validators, gRPC as well. So it's like, but none of them are done in the same way. So to use the parsers, to use the tools for each of the API styles, you have to learn a completely different process, and that's a pain, right? And I think that, you know, to to make it better in the future, I think this tool uh, need to be becoming interoperable between them. How? We need to figure out. But I think these tools need to be playing with each other well. Um, Also, I think in terms of tools, we have authoring tools like Postman, Stoplight, and Swagger as well. So I think we're kind of getting there. And the cool thing is that everything is open source, so we're there, right? So that's really cool. But like I said before, I divided everything by specs and tools, but there's another dimension, which is people. And I think we're failing. We all are failing here. So some of us are running everything with transparency. We try to be as transparent as possible on Async API, but not all the organizations behind the specs are being transparent, and that's something that we should change, and that's something that we should be calling out ourselves, not just ourselves working in spec, but you, the users as well, should be calling out. The process needs to be transparent for everything, right? Um, don't gonna extend more here so I don't run out of time. I think just to wrap up, um, I would like to reinforce that the API ecosystem is diverse. So I would say that nobody can be working only on Async API or working only on OpenAPI or on GraphQL, because then we'll fail together, right? And that's because that's what's happening right now. So we're not ever considering that the user might want to use GraphQL together with AsyncAPI. And so the user experience is going to be different than a person that only wants to work with AsyncAPI alone. And I mean, I'm saying like collectively, we're not thinking about it. We are at AsyncAPI. As you can imagine, this talk is about the future of API specifications. So this could be giving you some hints of what is the future of AsyncAPI as well, right? So if we think that this is a future of API specification, we're always gonna bet in this direction, of course. So yeah, we're gonna be betting on specs becoming composable and extensible, and I hope we are not the only ones betting on this. And tools should be facilitating evolution and interpretability, like I said. This is really, really, really important because tools, so spec without tools is just nothing. Because like, why do you want to have a spec if you don't have tools to use it? And spec authors must collaborate with users, and not only with users, but between them for the benefit of the user, and to make it clear, like the users will be in the center always. And this is just a call out to other spec maintainers. So please, let's do it. Let's put the user in the center and learn from them, and instead of isolating ourselves into a small group of API specification authors, right? And I think we have some time for questions, so maybe afterwards, you tell me, Bill.
Yeah, after would be awesome.
Okay.
Yeah, thanks, Fran. This was a really unique presentation. I think it was great. It just shows the power of like the API community to like have all these events, you know, where you're kind of learning things about the how the specification is being received. It really shows the power of people to really drive home a single nagging idea. And that was something I've been asked at conferences too, and I didn't have a great question or response to that question. So this helps tremendously. Yeah, I think it's great to be thinking from the user's perspective, like you're saying. You know, we get so often just trapped in our own vision of whatever we're working on, when in reality, this is, like you said, just part of the larger puzzle. There's so much more to dive into. Everyone who's listening in real time, feel free to, you know, drop your questions, and we'll get to it in the chat after Ben's session here. Just to mess with Fran, I dare a listener to ask why we shouldn't merge async with OpenAPI. So I'll just throw that out there.
Ben, I didn't understand.
Oh no, I dare a listener to ask that question again.
Okay.
Just to be in theme of all your previous events. Okay, Ben, we're gonna shift things over to you right now. So take it away whenever you're ready.
Excellent. So the inevitable thing of let's see if this shares. Can you all see?
Looks good from my end.
Brilliant. So welcome to my little talk about async communications, a bit of the past, a bit of the present, and a bit of the future. There will be puns, some of them unintentional, most of them intentional. So let's continue. So who am I suppose? So whereas Fran is quite well known in the space already, I think possibly the only person who actually knows me is Fran. So my name is Ben Gamble. I work at Ably Realtime as head of DevRel. I'm the sort of person who makes people read the Phoenix project by literally giving them physical copies until they do. Get excited by cool things. I use a lot of APIs wherever I can find them. And famously, as Hacker News will tell you, we don't use Kubernetes in production, even if it takes down our own website in the process. That was a fun day. So let's talk about a little bit about Ably before we move on to the kind of key thing. So Ably, real-time communication platform. We empower digital experiences, lots of connectivities, huge wall of logos, but you don't want to read that. So what we really are is a highly available PubSub message broker, right? We built scale out, think Kafka that goes from your data center to your phone, except you can have unlimited topics at any time you like. That's sort of what Ably is, but with a lot of WebSockets connected. And it's kind of important to set the stage with this, because this is kind of like what I do, and therefore where this is all coming from. So let's start about asynchronous systems, because it's not really worth talking about asynchronous communications until we know what is asynchronous. So this is going to be a bunch of Euclidean assumptions. So these aren't things I'm going to try and validate or prove today. These are just kind of statements almost. So when you're dealing with complex stuff, like, and anything I mean significantly complex, I don't mean math operations, I mean disks, I mean network and the rest of it, you kind of have to wait for it to happen. And it nearly always happens off the main thread. So, you press go, and you want to keep pressing while something is happening. And users are, should we simply say, very impatient. And so what happens then is you return control to wherever you were, and until the thing comes back, you come back. And then when the thing returns, a promise would be an example of this, a future would be an example of this. There are various ways of basically wrapping up an interrupt loop, which is still going round and round and round and round in a rapid polling thing. When you unwrap it all the way down, nothing is really asynchronous. Instead, things are just constantly checking. Asynchronicity is important because it's about efficiency. It's not totally more efficient than truly synchronous code. However, it gives a much better impression of efficiency. It also makes the most of when things can't be done because you're waiting for an external resource. Now, the classic analogy I always like is, are you watching a pot boil, or you put the kettle on and wait for a sound? It literally is the computing equivalent of this, because the line is, you'll never watch a pot boil. Or you ever watched a file handler complete on Windows with that little thing ticking across, telling you it'll be 3 days, 10 minutes, or 6 weeks? It's one of those kind of examples. You don't want to be stuck there. Instead, you want to press go, do something else, and when it comes back, it'll ping and tell you. And that's what your computer really wants to do, so you don't get a horrible user experience. Now let's talk about communications. So as things go in computers, networking is about as complicated as it gets, right? And this is because you're talking guaranteed between two machines. So you've already got a distributed system by default, and there's no such thing as making problems worse by adding more computers. And the speed of light is bizarrely slow when you actually get to talking between computers. Like, distances are real. In a past life, I used to work in AAA games, and the fact that it took 100 milliseconds to go between two places and a frame was 16 milliseconds meant it was very weird when people complained about frame rates, when literally the fastest they could ever see something was 116 milliseconds. So it's one of those things where the network itself is often your enemy, but also your CPU doesn't want to wait for that 100 and something milliseconds in one direction, 100 and something milliseconds in the other direction. So what happens is you fire the request and want to do something else while it's going on. And the key thing here is that you don't even know if you should be receiving messages most of the time. Like, you literally have an open port somewhere waiting, and your OS is going, is it there? 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 And whether the message will turn up or not is something you don't know as the user most of the time, which is where this kind of thing comes from. So, like, this is where we get down to kind of synchronous versus asynchronous communication. So one is literally, hi, I'm talking, wait for a response. And the other is classically like the kind of the postman model, where you send a whole bunch of requests, something else gets them back. And this is where I'm going to define one of my things about asynchronous communication is, asynchronous communication does not rely on the receiver acknowledging the sender directly to continue. So the sender can continue while the receiver is receiving. Acknowledgements may happen, but it's not in the same protocol layer. So even if it's a TCP connection and there are literal, IP frame acknowledgements coming back, it can be asynchronous because at the level you're at, let's say it's layer 7, you can asynchronously keep communicating, even though at layer 4, every single packet is in fact synchronous. This is important because of where the data lives in the stack. And let's talk about why this matters a bit, because without that, it's kind of like, why would we bother? So if you look at the kind of the massive flow of people here, is these are messages going through. Now, if every single one, if you couldn't send the next person through until they've walked from one end of this road back to the other end, and have to keep doing it one by one, even if those people went very fast, your maximum in-flight things is a bit bad. If one of those requests takes too long, suddenly you're blocked. So this is often referred to as head of line blocking, and it's a classic problem in TCP networking. But as you actually go up the stack, out of the kind of IP level and up into these higher level protocols, it's still a problem, and it gets worse because you're amplified by every other layer of blocking below that. So let's talk about HTTP. And the people who will show their age here by recognizing the Mosaic logo, the first web browser, and of course Netscape, the better web browser, and some would say the best still. The key thing here is that, like, HTTP started off life as like a way to get stuff on screens over the web. What it became is the de facto way computers talk, right? And by computers, I mean any device which can do computation. I mean your phone, your desktop. Hell, a load of IoT devices still speak HTTP because it's the most common thing. Work has been done to make HTTP work at scale. And the one thing we do like as programmers is not doing the work ourselves. So if there's a way to make it work, you'll use it. And HTTP, it damn well works. And as we continue, like we get to kind of understanding what's actually going on in HTTP, which is, let's start with HTTP 1.x. And I'm going to say 1.x because 1.1 is still bizarrely as unsupported if you dig deep into the web. But HTTP 1.x is very synchronous. There's a maximum number of in-flight requests. You can do things like domain sharding and pipelining, but it doesn't really solve the problem, right? You know, persistent connections in the actual kind of live spec actually make things faster, but they don't solve the actual synchronicity of stuff. WebSockets sort of do, but they are persistent and need to be maintained, and they are more complex than a lot of people want to deal with. Hence why they come to us at Ably. But irrelevant for this bit. The next thing that happened, of course, is HTTP 2. Now, HTTP 2 is what gRPC is built on top of. It's part of a Google protocol called SPDY, I think, though I've probably got some of those acronyms mixed up. And it allows for a lot of asynchronous stuff because it is multiplex by default. You don't have to wait for the previous request to complete before you send another one. And it's all binary based. So there's a lot of performance gains all the way through the stack, but the most interesting one is the ability just to keep firing requests in and then to come back in any order. Although it still has head of line blocking because it is a TCP based protocol, you're not blocking at a kind of bigger request level. You're only blocking on a byte level. So it is a hell of a lot more asynchronous than HTTP 1 point anything. Now, this is really important because something like gRPC is you don't know how long an RPC is going to take. So I want to be able to send 20 RPCs off to a server. One might take an hour. One might take 15 milliseconds. I need to be able to get the one that takes 15 milliseconds back afterwards and not wait the 1 hour for the first one. And that is really important. And when we get to HTTP 3, things get spicy. And we're in UDP territory. So UDP is a connectionless protocol, which basically means that although we do a handshake, we can just stream stuff. There is no head of line blocking at all. So this is a fully asynchronous protocol, and it could truly revolutionize the way the web works and change most things forever. But to be honest, it would also require a lot of hardware to change. There is literal hardware problems in implementing HTTP 3 because there are various networks that physically block UDP packets because they are inherently unreliable. Though they can be made reliable, it's simply the fact that because it was unfavorable for such a long time, that people like Cisco have made decisions to make it really hard to make something like HTTP 3 everywhere. That said, it's absolutely amazing what you can do with it. If only it wasn't so difficult to find support. So what do you need when you want to do more than just communicate between, a server and a browser? Well, let's talk about PubSub. And this isn't submarines and pubs, and it is not those lovely sandwiches, which is what I get every damn day on Twitter when I try to actually do my job. It's a pattern, a really kind of important design pattern. And this is where we can get asynchronicity into anything, because what we can do is we can decouple things. The idea here is we have a broker in the middle, which is some machines, and it is some machines, but it could literally be a process in your computer, or it could literally just be a buffer in RAM somewhere, because a PubSub applies from your own machine all the way up to multiple layers of distributed systems. And the key thing here is inputs go in one end, something does some processing and routing, and receivers are at the other end. And there's a disconnect between these things. So the famous examples these days would be RabbitMQ, Kafka, NATS, and MQTT. Now, the key thing here is that they all do this very differently. NATS tries to do a bit of all the above, but the key thing here is that they're all existing for specific use cases, but they implement this pattern. And the pattern is the powerful bit. The actual implementation is about a use case, nearly always, but it also means it trends towards activity in various regions. Kafka came around from LinkedIn, where they wanted to do logs gathering in one place. They wanted to have a known set of good information to work from to optimize their website, to have events gathered in one place, so it had to write to disk. It's also optimized for spinning platters, which is why occasionally you look at Kafka going, this is really strange, but when you realize it was all built against mechanical hard drives, all the decisions are really smart. RabbitMQ is much older, from JP Morgan of all people, and it was about trying to just route messages around a bank with a really clever protocol. And that's why it's AMQP under the hood. Rabbit is just an implementation of AMQP. AMQP is the advanced message queuing protocol, and it is unbelievably advanced. And things like ActiveMQ and all the other MQs you've heard of are actually bizarrely similar to Rabbit, just subtly different in what they implement. There's a big spec divergence here between what's known as 0.9.1 and 1.1. And everything you've heard of in JMS is 1.1, which is all active MQs, and everything in Rabbit is 0.9 stuff. And as you start going into the details of what this means, you realize that although it all look the same, they all are wildly different. Nats is effectively trying to be Kafka, but more friendly. Is the best way I can describe it, but it's such a broad protocol that it's really hard to define in anything beyond that. MQTT is the de facto, by popularity, IoT protocol. Is it the actual most popular IoT protocol? No one knows. Most IoT things get very proprietary after a point, and it's very hard to actually tell what's going on. Things like lightweight M2M are massively kind of moving in on this territory because it involves more than just data. It actually involves device management. And the key thing here is these are all still PubSub patterns and PubSub implementations. All the ones I've listed here are TCP based, right? MQTT is about trying to minimize the amount of data in a chunk so you can keep throwing them over the wire and deal with failures very cleanly. Rabbit is about just being able to route things into good queues to consume from, to make patterns which allow for very strict, I have done this exactly once consumption models. Kafka is about storing messages in the most resilient possible fashion. Anyone who tells you otherwise is not really talking about what actually Kafka is best at, which is the resilience factor. Kafka is used because it is the most reliable part of a network, and that's what it's best at. The fact that it processes streams great is a wonderful side effect of the reliability you get. And Nats is sort of there because people wanted something better than all the above, which means it has a bit of this kind of mixed message about it. But quite frankly, I'm really excited to see where it goes next. So they exist to provide these loose coupling. Regardless of which of those I've mentioned, everything is all about trying to encourage decoupling things. So you use Kafka because you don't want your producers who are spooling a million messages per second to have to overwhelm anything at the other end. You also want to be able to scale that middle layer. You know, in the case of Rabbit, saying I have tons and tons of work queues that all need to be consumed exactly once, but I don't want to have to worry about my workers being able to actually hold this stuff in memory. So I instead can scale Rabbit in between. I want the pace to go in any way they like. So particularly with MQTT, your literal sender might only be able to send one message every minute because the CPU is that slow on a literal hardware clock. So what happens then is you need to have something on the other end that can consume really rapidly from a billion of those devices. And the other thing you get, which is fun, is strong guarantees. Because you can actually do this decoupling and this speed decoupling, you can make stronger acknowledgements happen between two systems without ever trying to truly impede the full end-to-end throughput of your system. So you can do things like pass a packet in, start processing it onwards, ACK it back once it's on disk, while it might have even reached the other end by the time the first ACK has got back. Because these things can be fully decoupled. There is nothing to say you can't onwards process a message before it's ACKed. It just means that when the person receives the ACK at the other end and says, this has definitely happened, I've got the strong guarantee, it might have completed, but they know for a fact with the guarantee, which takes time, has happened. Now, this is where asynchronicity comes in, because you need to decouple these systems to allow this to happen at any level of performance. So what's the issue with all this? Surely this is all kind of plug and play, right? You know, you've got all these systems, they're all off the shelf. Most of them are at least 10 years old. Well, they don't plug and play, right? Loose coupling involves service discovery. Each of these things speaks a magical binary protocol rather than just JSON or plain text like HTTP. HTTP's magical source is the fact that it is plain text. It is the boon of HTTP and the reason it succeeded, but it's also kind of its death knell in some respects, and why things like HTTP 2 needed to come about is you do need binary at a certain point for efficiency. So what happens now is you have all these protocols, right, which all speak subtly different languages, and now you have to manage a system with n different things inside them, and you just do not know what you're actually up to sometimes, because you're saying, right, I'm consuming off Rabbit. What does that mean? What do I need to do? And so you need a contract. And this is where we get to the async API stuff, right? You need nouns and verbs on this API contract that makes sense. The machine needs to agree outputs and need to verify success, right? And it's very important that you can do all these things at somewhere in your system, because otherwise, like, how are you supposed to have a reliable system that does a bank transaction if you can't guarantee the machine side that you receive verifiable data? How is it easy to build with a big team if you can't agree what is a producer and what is a consumer? As Fran will happily tell you, that this kind of language is hard to get right. What is a server is even something hard to agree at times. And your expectations from the data are important as well. Like, you have to be able to read it. You know, there's often a time criticality to things, and it's got to fit. Like, this isn't kind of loosely typed stuff at the end of the day. This could literally be like a medical record. You can't misinterpret that and miss bytes off. It's not acceptable. And with any of these systems which is reliable, reliability comes in a big way. So then, you know, we've heard a bit about async API already. And the key thing here is that, like, providing a way to basically wrangle the fact that we know two things nearly always going in. We know the format of the data, and we want to know where we're getting it from. And then what we can rely upon is machines. We can basically feed an async API spec to a machine. It will generate the actual, against the SDK, which it knows about, it will generate a way to get the data out and verify it. And this is why async API is quite powerful, and why I'm quite a big fan of it, having an actual async API as my day job, which is Ably. And it's magical because it means I can talk to other services as well. I can convert from one to one to one without ever losing what the magic of each of the ones are. So Kafka's lovely for this data that needs to be there every damn time, but it's terrible for trying to get one person to get that data out of a million people. And it means I can do things like verify the data came off, do some information to it, and then republish that on to someone else who understands how to get it again with the same schema, with the same data layout, and with the same guarantees. But now let's talk about, we talked about, you know, the what and the how, but why and why now? Because, like, the key thing here is that a lot of the stuff about HTTP, that's in the 90s. That's the past bit of this talk. And the current bit is about the Kafka. But the why now thing is, devices are everywhere. Like, the growth of internet usage is kind of insane. In 2019, it was 51% of the world's population. And now it's about 61%, right? And if you think about what that is in population terms, it's about 700 million new internet users, right? And there are more data, there's more data now, there are more spikes in data because there's one thing people like doing, it's the same thing as the person standing next to them, right? So now you have bigger spikes in usage, you have bigger spikes in data, and a much higher expectancy because of the fact that everything has gotten faster. Now, there's nothing worse in user experience than loading bars or just waiting for stuff to happen for no good reason. We've gotten pretty good with asynchronous UIs, but as data becomes the key commodity here, it's really worrying when you press go on a transaction payment and there's no return to know that the data even got to the bank. And there's no way to know it's being processed or what's actually going on because it's a synchronous request. Now, this sucks. And as a user, it gets really bad. And reliability can't easily be achieved with synchronous systems because basically it's all or nothing fail, which is great in some respects, but it's also terrible because I'd like to be able to retry part of the problem. Or if I transferred 20 things asynchronously, if I missed one, just do that one again. Don't do the whole thing again, right? Don't block on the one somewhere in the middle. And the problem here is that, like, particularly as things become more connected, things become faster, and the change in tech comes faster, loyalty requires reliability, and it requires an experience that matters. So you can't really mess around anymore here. Like, in the early days of the web, you could do almost anything and people would just go, it's new. And these days it's a commodity. Like, commodities can't fail. It's not allowed. It's a building block of people's lives. Like, I don't really carry cash. I barely carry a card. I literally use my phone for everything. So if that stops working, I'm in a bad situation. And this is where you have less room for failure. And I've already talked about this, but people hate waiting. They really do. So you can't really rely on asynchronous communication anymore. So the next question is, what next? What is the future here? Now, thing is, like, everyone is saying, 5G, lower latency, up bandwidth, and the rest of it. And, for things like self-driving cars and bigger connected devices, which require all this extra stuff, you think, what's going to change? What thing? And it's all the same, right? All you've achieved is fatter, shorter pipes, which means you still need to have asynchronous communication. Otherwise, you're still in a bad situation. It doesn't matter because the server you're working on, it has a lifespan of 5 years and its disk write speed hasn't changed. So uploading a file might take a little less time, but you're still going to run into some walls. And as expectations rise, so does performance. So it still matters to decouple things. It still really matters to make things asynchronous. And though this is a bit facetious, we can do it better. So it's really about saying, although the problem's the same, and the thresholds do move. And to be honest, we could all be better at this right now, right? Whether or not it's simply the fact that, like, we move away from some of the more synchronous systems that exist, use specifications to better define asynchronous specifications so that people can talk better over async. Because the number one problem I have with asynchronous stuff is that everyone speaks REST. Very few people speak WebSocket. Even fewer speak MQTT. And no one speaks Kafka, except internally. So suddenly it's like, how do I make it that everything like this can talk? Because, right, we're building an internet of everything. It's not an internet of things, it's an internet of everything. And at a certain point, 90-something% of it will need to be asynchronous because we're not programmed as humans to wait very well. We just want stuff to happen. And that means you don't know when a connection is going to come. You don't know when load is going to come. You've just got to be asynchronous. Thank you.
Hey, Ben, awesome presentation. Thank you so much. Yeah, really great overview of like the end business benefits of the whole asynchronous trend. I mean, I'm really glad you're talking about like increasing end user experiences and just like the rising tide behind that. I mean, I recently covered a report saying about 85% of people say applications and digital services are now like intrinsic to their daily lives. And most of them are just going to throw an app away if it's not performing correctly. I mean, the whole like site reliability engineering role has gotten so much interest lately, so like ensuring awesome integrations is just part of that, it seems. Yeah, thanks for like having a great overview of all the protocols too. I think that's something that I want to dig into more with Nordic APIs and kind of the need for a common specification. I'm curious though, you say like one of the best benefit of using something like AsyncAPI is because it's magical, like you said, you can have these different services talking to one another. How common is it to have so many different competing protocols like within the same project? I mean, is that like a common scenario?
I wish it was less common. I wish it was less common. So I'll answer a bit first, because like classically, like the service we provide can be spoken to as REST, as our own WebSocket protocol, which is custom just because. You can talk to as a WebSocket. It's difficult, as Fran will tell you, for no good reason. You can also speak MQTT, SSE, and a few others. And like, that's a lot of different things for just the single service, but we're spoken to as if we are Kafka, as if we are MQP, and a few others as well. So suddenly it's like, as one service, I have 12 protocols, I think, at last count. And my customers nearly always have the same number, but they're all different again.
That's hilarious.
Yeah, and I think, sorry, I just wanted to...
I was going to ask, yeah.
And I think that, think about it, like, if you have a, let's say, microservices architecture at your company, and everything is communicated through Kafka or any other broker or whatever, then you're already speaking Kafka, right? But your product might have a user interface that is using WebSockets to update in real time as data is flowing, right? So just now you're using Kafka and WebSockets and HTTP most probably. So you're already using 3 protocols in this simple example, right? And if you're using not the web browser, but you're using mobile applications or similar, you're probably leveraging MQTT as well, because works better on these devices. So yeah, it is super common to see mobile applications using, especially those who are data intensive, like Uber or any other
Any of the mapping or travel
geoposition.
apps.
Yeah,
they're
travel
all-
apps. Geoposition, usually it's a good use case for that, and chats. So these all work under MQTT most common, right? It's the most common choice. But then after behind the scenes of your of let's say the backend, if you want, then MQTT might not be the best choice for you. So then you have to republish the same data to in Kafka format or in AMQP format. So this is more common than Benguish it was.
Right.
It's even more fun sometimes, because if you look at the publicly
Yes.
published things for, let's say, Slack, is like, so Slack's APIs go something like WebSocket into Redis, into Kafka, into another 2 protocols before it might come back again through the same pipe out.
Dang. I've heard on this call alone, some specific areas where we're seeing a lot of this async, development. Like I think both of you mentioned financial services, banking, healthcare, geolocation, IoT. Do you see these as like kind of the common areas where you're seeing a lot of this being applied, or would you identify some like other use cases as well?
I think it's where it started. I think I'll start on this one. So I think what you've described is where it really has started and exploded, but it's sort of spreading outwards. And it's like, because like inevitably where the money is or where criticality is when it's going to really bite. So financial services is the obvious one, and then healthcare on the other side. But as soon as, once the tech is commonplace, every single consumer app is like, if I be 20% faster, my app store rating goes up. And, that's all it takes to basically make $1 billion company a $10 billion company.
Right.
Totally. And another one is that I would like to mention is advertisement as well. Okay. So advertisement is, if you want to create an ad company to compete with or to provide like a pool of ads for other services like Google ads or Facebook ads or something, then you gotta be quick. You gotta be fast, right?
Yeah.
Because the faster one wins.
Real-time bidding protocol is harsh. It's a tight spec.
So that's also a one industry, I would say.
And cybersecurity as well, with things like taxi and stick speeds are exactly the same, because like they're another JSON type schema, but that literally says deliver me as you like, but it probably needs to be asynchronous.
Yeah. What about APIs like in the cryptocurrency, blockchain, distributed ledger kind of spaces? Are you seeing the need for like documenting asynchronous connections there?
Only from like the brokerage houses to users, like gate prices. Okay. I've definitely seen a lot of that. The actual on network stuff, I'll be honest, I don't like it's been a few years since I looked into the Ethereum project, and I've not really seen it much. Documentation seems to be something a little alien to, if anything.
Because I'm seeing a lot of APIs, but like you said, it's mainly for like sticker or ticker prices and stuff like that. Yeah.
I haven't heard from there as well.
Cool. Yeah. Okay. So something that Ben mentioned, and I feel like it relates to what Fran's saying pretty well. Is like you're trying to dig into the actual implementation behind IoT devices, but you're finding like there's a lot of proprietary stuff here, and it's hard to know what actually is being used under the hood. So like, but Fran's saying we need to increase interoperability, have the specs working together a little bit more. So what kind of roadblocks are we facing with the future of AsyncAPI and specifications in general? Knowing that there's some proprietary potential issues there. This could be for either of you, really.
It's a very good question. That's actually the problem.
That's a very good. No, actually, let me just answer politely. I think it's all people in the end.
Yeah.
And so it's, I don't know, business interests and things like this. So it's politicking, basically. It's what's blocking most of the things. So like I said before, it's not a technical difficulty or anything. It's not a challenge for in the technical side. It's more about people, and when you have to deal with different interests, egos, business interests, things like this, when you have to fight against this, you probably are gonna fail miserably, because if you want everything to align, let's say, and come up and work in the same direction, the very moment you have just one of them not wanting to go in the same direction, it's gonna fail. So it's hard. It's hard because of people, not because of technology. And we see, for instance, also business interest being part of it. Like, for instance, GraphQL is part of Facebook, or started at Facebook at least, and gRPC is owned by Google. So I mean, I'm not saying that they are not in the mood to align the, let's say, the direction with the rest of the specs. Actually, I think they will probably be the ones more interested to do it. But yeah, like when there's money around, there's always dark things. Yeah.
Also,
right?
counterintuitive interests is always the interesting one. So if you look at the open firmware movement, it's kind of I see a lot of mirrors here, because like Intel and such don't often want to publish what their firmware is doing for all kinds of both good and strange, we'll say, reasons. And like eventually it becomes a point where either it's in their commercial interest to share it because they're going to lose out on an opportunity, which is I think what's going to happen. And it'll become open because it'll be a commercial risk not to be open.
Right.
Versus versus they see it as a commercial gain to become open now. They you kind of need to have them follow along and expect that and make this thing good enough that anyone who's new in the space is going to start here.
Yeah. I kind of, when I first started, getting interested in APIs, I did notice like a little bit more open developer programs around hardware stuff like IoT and, smart home, smart city devices. I don't know if it's just me, but I've seen like a little less excitement around that. Has it become more proprietary, or does that stuff like still exist? Is it less of a commercial imperative?
I think it was more just the actual whole interest in the space went down a little bit.
Yeah.
I remember like my first job where we were talking about connected cities back in 2010, and it was like the big thing. And the internet, and like it was like the internet thing, it was on the rise again. And it was the internet connected toaster joke was the one that kept coming round and round and round, the toaster on the internet.
Yes.
And I remember the partner in charge of the project was saying, well, I did that in the 90s. And it was a good joke then as well. And the fun thing is that like I think if anything, it succeeded and it didn't drive anything. Like, like the open light bulbs from Philips were quite popular, but it's just the fact is they got outcompeted by other people who were quite proprietary.
Yeah. Well, hopefully we'll see some other open developer platforms emerging in other areas.
So the biggest win, by the way, has been the Raspberry Pis. These things are just driving everything forwards by just being too good and too easy to use.
That's awesome. Maybe Ben, we could just figure out, we could end with one question for you. Let's see if you learned something from Fran's talk. Why doesn't AsyncAPI merge with OpenAPI?
Oh, well done, well done. So from my perspective, it doesn't need to, right? Like they both have a domain-specific use case, and quite honestly, like trying to get an organization to adopt OpenAPI alone is a challenge. Right, getting to do it right is another challenge, and on most cases, the asynchronous part of your API does not serve the same purpose as your REST API, or if it does, it's alongside it. With REST, it's nearly always an enhancement to have async, or your internal, and async is the norm. So because they live in different domains and are often motivated by different groups and different teams, actually having a spec in the same place would probably cause more confusion than it would gain. But there's need to alignment because, to be honest, the closer they're aligned but subtly different, even if it's just name alone, is the best answer. And It also means we can maintain tools more easily. The tooling alone is what makes these specs worthwhile, right? Having a specification that people have to follow manually is rubbish, right? Like they're there to stop people making mistakes, not to add another vector for mistakes to be made. Like, trust me, there are enough of those. I don't need more. I don't need more. And it just means that, like, just because I want to have two different specs, having them on the same page doesn't mean anything. And like having them on the same tooling is actually worse, because now that tooling cycle is even slower. And now I need more people to maintain it. Whereas, like, you know, I love working with Daphne. I do not like working with REST APIs. So I would never maintain an open API tool. I'll happily maintain a Kafka tool.
Thanks for tackling that. That was brave.
Just channeling Fran there hard.
Yeah. We did get one question in. Let's pivot to security for a second. So what security can be applied to AsyncAPI? Because OAS allows for things like OAuth 2.0 and other options.
So let me answer this with sharing my screen.
Sure.
So I think it's going to be easier because there are a bunch. So this is everything that you can define using the security scheme object on AsyncAPI. So basic authentication, like, you know, user password, API keys, certificates, and encryption, HTTP authentication, and I'm going to get a little bit deeper there. HTTP API key, which is different than API key, and all of two common flows, right? OpenID and SASL. So HTTP authentication here, you have different approaches. Actually, no, yeah, that's okay. It's not HTTP API authentication. It's OAuth 2, so it's here. So there are, as you can see, there are many. Why? Because to send a message to a broker or to receive or to connect to a broker, the broker itself might be exposing an HTTP interface that then it will upgrade to something different, or that will give you a temporary password to access via user password to the router, to the broker. So there are many. Let me just share this here with you so you all can have it. So this is the link that I was sharing. So yeah, there are many. There are many. Let's just two.
We'll share that link in the show notes as well. Yeah, Ben, are you discovering any sort of security preferences in your work with asynchronous APIs?
It's kind of fascinating because the problem of all the things we're actually defining kind of usage of is they all have their own security measures and access control lists and all the rest of it. And like the fact of the kind of the key thing in AsyncAPI is flexibility, right? We've accepted the fact that we're talking asynchronously. We've accepted the fact that the schema could be quite different, and we can link to other types of schema, which is possibly the most powerful thing it does. It's not really about just being the spec you use. It's about being the spec, you know, the canonical reference where all the bits of the specs live.
Right.
So it means that, like, for security, you know, things like this access is great. For like tokens we generate for our product is we actually use the spec itself because it defines the topics, and then you can simply say for a topic subset which is defined in the spec, generate that token with access. So the cool thing is like, yes, we have all the flexible things for Amazon, but you can go further because it can be done on a per protocol basis because that's the generator, and the generator can be more advanced if the access control mechanism is more advanced. It is a bit of a weird answer, I know, but the point is that this is not like you don't solve all problems in one place. The spec itself is core, but the generators are what makes it magic.
Interesting. I think I'll have to rewatch to completely unpack that. Hey, Fran, we had one more follow-up question. Maybe you could explain like the difference between an HTTP, API key versus like a general API key.
Yes, so let me put it that way. So message brokers usually expose a single protocol interface. In most cases, like AMQP, RabbitMQ, for instance, expose an AMQP interface. And the AMQP authentication is very let's say simple, is most of the times is user and password. So because it's not meant to be public, it's meant to be something internal. So what they do is they expose the authentication as user and password. But some companies are exposing the broker externally for users to connect, and you can't give every user the user and password, because then you will have problems, right? It's like people will people will try to do bad things on your broker, right? And so what they do instead is they give you an API key that they generate out of band, and they create a user for you. So they create a user, and the password is this API key. Or they simply do something which is, I give you this API key and this is your username, and leave the password empty, right? Or leave the user empty and put the API key as the password. So these are tricks, right? These are tricks that they're hacks they're using to give you the ability to have API keys on servers, on brokers that are not meant for that. So that's API key, right? And then HTTP API key is what we all know. It's like you can have JWT, JSON Web Tokens, or you can have better tokens, or API keys basically that you can provide through HTTP, through the HTTP protocol, if the broker accepts this protocol, of course. So
Okay,
these
great.
are the different things.
Yeah, thanks for helping to clarify that.
No problem.
All right, everybody. I think we've gone a little bit over the time, so I think we'll end it there. Thanks, Fran. Thank you, Ben. Great talks, great discussion, and we'll be posting the recording soon. Yeah, thanks for tuning in with us, everyone. I just have, yeah, of course. Thanks for coming in.
Thanks for having us. It's been really good.
Yeah, it has been. Likewise. Your first Nordic APIs talk, Ben. I hope we can have you back, especially once we get normal conferences up and running. So I just have some wrap-up slides I'm gonna bring up. So yeah, thanks so much to our speakers, and thanks to everyone who tuned in live and helped generate some discussion. First off, just some quick updates before we leave here. We recently put out a new ebook, API as a Product. This one is great if you are working on a specific API-centric software as a service and trying to monetize it as an API product. Like all of our ebooks, it's completely free to download without an email gate. You can just go to our nordicapis.com/ebooks page to pick that one up. Maybe we should do one of these on AsyncAPI in the future. If you want that, let us know. Maybe we can do some collabs there, Fran. And just putting it out there, if you're a listener and you love APIs and you want to share your story with our community, our blog is always open for those sort of contributions, as long as they meet certain guidelines, which it's all described right there. We also operate a newsletter featuring updates every other week from our writing team. So sign up there if you want some more API knowledge right in your email inbox, so you don't have to always be doom scrolling on social media for this kind of knowledge. And our next live cast, I'm happy to announce, is going to be at the end of next month. We're going to be investigating the new intersection between APIs and the emerging low-code trend. So low-code, no-code saw a major uptick throughout the pandemic, and we're going to be exploring what effect that shift is having on the API economy, and maybe how to bridge the pro-code, no-code divide. So that'll be super interesting. We've got some good speakers lined up for that one. And we do have an ongoing call for speakers. We are going to be announcing some physical events soon, so that's up and coming. Stay tuned for that. And as usual, thank you to our sponsor, Curity. You can learn more about their OAuth server and identity-driven API security solutions at curity.io. So that's all we've got for you today. Thanks for listening. Hope to see you at our next event. All right, bye.
Bye. Thank you. Bye.
Thank you.
Bye all.